All right, so far we've just been using trigonometry to find the lengths of sides that are missing in a triangle. It turns out, God bless you, that if we have two sides of a right triangle, we can find any of the angles of the triangle. Okay, and the idea is basically this. If we have the square root of x equals 7, we can find x by squaring both sides, right? Because squaring is the opposite or the inverse operation of the square root. All of the trig functions also have inverses. So the inverse of sine is called sine inverse, or you can call it inverse sine. I've seen books do both. It doesn't matter. And the way that it's written is this sine, and it looks like it's being raised to the -1 power. This is my least favorite symbol in all of mathematics because it's like, well, that also could been an exponent. This is the symbol for sine inverse. So please don't say that sine to the -1 thing. It's sine inverse. Okay? How does that work? Well, let's take a look. If we're on this problem and we're trying to find the measure of this angle at x to the nearest tenth of a degree, well, what we can do then is we can set this up just like we normally would. 67 is which side relative to the angle at x?
Opposite.
Opposite, and 43 is?
Adjacent.
Adjacent. So that means I'm going to use tangent. So I've got the tangent of x is equal to 67 over 43, right? To get rid of the tangent, just like getting rid of the square root, you would square both sides because that's the inverse. I'm going to take the inverse of both sides, or the inverse tangent of both sides, so that I get x is equal to the tangent inverse of 67 over 43. At that point, you have done the algebra necessary to get x by itself. So you grab your calculator. I have to wake mine up. And notice right above the tangent button in blue is a tangent inverse. So we do second tangent for the tangent inverse of 67 over 43. And it gives me that this angle is approximately 57.3 degrees. That makes sense? Yes?
When we do problems like that and it tells us to round and we get lots of decimals like that, do we need to put an approximate squiggle?
No, because it told you what to round it to. That's an excellent question, though.
Okay.
If you decide I need to round this off and it didn't tell me what to round it to, you would use an approximation symbol. But this is the exact answer to the nearest tenth. It's a great question, though. So let's real quickly do one of these. I think I'm going to cut one because we're a little short on time. Let's do this one. What sides do I have in this case? Adjacent and hypotenuse. So what are we going to use? Cosine. So the cosine of x is going to be 28 over 95. Solve for x before you do anything else, so that x will be the cosine inverse of 28 over 95. Joey, you with us? You're doing what with it? Oh, do you not have a calculator? Okay, you got to have a calculator. All right. So, chuff that into your calculator. Somebody tell me what that is to the nearest tenth.
72.9.
72.9 degrees. Okay, any questions about that? We'll skip number 3. I think you got the idea. So, in these problems, we're going to do what's called solving a triangle. We're going to find all the rest of the sides and all the rest of the angles that aren't given to us. Okay? I think the simplest one is one like this, where you're given two sides. And I'm going to change this one just for grins so that it's different than another thing we're going to do in a moment. Let's say that the hypotenuse is, I don't know, 12. Okay? All right. So, well, how are we going to find we've got two of the sides. I'll go ahead and find the third side. How can you find the third side? Yes?
How do you know what it's like adjacent or opposite to? Where we?
Well, I'm just finding a side right now. Has nothing to do with trigonometry at all.
Oh,
Has to do with things you learned in 7th grade.
Pythagorean.
Yeah, it's the Pythagorean theorem. 7.5 squared plus st squared, it's okay, no one else, was jumping on it, is equal to 12 squared. I would suggest that you solve this for st before you grab a calculator. I always do all the algebra work first and then pick up the calculator. Okay, so I'm going to subtract 7.5 squared from each side. I'm not even going to bother to square these because my calculator is going to do all the heavy lifting in just a second. Yes?
Why can't we say like 12 squared minus 7.5 squared is like, what would it be?
You mean 5.5 squared? No, it's not.
Okay.
Never will be. So now we'll take the square root. And st will be the square root of 12 squared minus 7.5 squared. And you can chuff all that into your calculator. The square root of 12 squared minus 7.5 squared. And it said round sides to the nearest hundredth. So st is approximately 9.37. Now, once you have done that, I'll go ahead and find the angles, just like we did on the previous page. Pick an angle. It doesn't matter which one.
Angle R.
All right, let's pick angle R. Let me strongly impress upon you how bad an idea it would be to use 9.37 as one of the sides when we're finding R. There are two reasons. Number one, it's an approximation. It's not exact to a bazillion decimal places. Number two, what if you screwed up and you found the wrong thing for the length of st?
Then everything's wrong.
Then everything else after it that you used would be wrong. So use what you're given. To find angle R, 7.5 is which side? Adjacent. And this is? So that's going to be? Cosine. The cosine of R is 7.5 over 12. So R is the cosine inverse of 7.5 over 12. So second cosine to get the cosine inverse of 7.5 over 12. And it said round that to the nearest degree.
51.
So the measure of angle R is about 51 degrees. Now, you can, if you want to, go ahead and do S the same way, doing opposite and hypotenuse, but you don't have to, yes?
Oh, sorry. I was looking at 6.89 minus 15.
Yeah. Although this is a rounded answer, S is going to be a rounded answer to the same amount. I'm not doing anything. If you're just adding or subtracting a rounded answer, it's going to be rounded the same kind of way. You see what I'm saying? I don't think I'm saying it particularly well, but you understand. If I use it in something like the Pythagorean theorem or something like this, there's no telling what all kinds of horrible things could happen. So this is about 90 minus, sorry, that's S. 90 minus 51 would be what, 39 degrees?
Yes.
For this next one, instead of getting two sides in a right triangle, we got one side and one acute angle in a right triangle. I always start with what I know 2 out of the 3 of. I know 2 out of the 3 angles, so I'm going to find this angle. Just by subtracting 58 from 90, it's 32 degrees. Notice that's not an approximation, so if you want to use it, you can. I again tend not to because I don't trust myself. I make lots of mistakes. Okay, so I would rather use what I was given. So if I'm trying to find AB, for example, from the 58, AB is which side?
Adjacent.
Adjacent, and 14 is?
Opposite.
So that's tangent. So the tangent of 58 is going to be 14 over AB. Again, I think I told you guys the other day, if you write that over 1 and go sideways, then AB over 1, which is just AB, is equal to 14 over the tangent of 58. And you can just chuck that into your calculator. Yes.
I'm confused about that cross multiplication.
I didn't cross multiply.
What'd you do?
I went sideways. I went this way.
Why wouldn't it be 14 times tangent 58?
Now, I'm not multiplying. You cannot multiply like this. But you can rewrite the proportion as AB is to 1 as 14 is to the tangent of 58.
Okay.
If you'd rather cross multiply and solve, that's fine also.
Okay.
It'll work out the same way. And we get that the length of AB is approximately 8.75. Did they say round to the nearest hundredth or the nearest tenth?
Hundredth for angles.
No, it doesn't say hundredths for angles.
Hundredths for length. Nearest degree for angles.
Nearest degree for angles, hundredths for lengths. Okay. So this side is approximately 8.75. Again, you could, I suppose, try and do the Pythagorean theorem and find AC that or BC that way, but that's a bad idea because you've rounded this off. You're likely to get round off error, especially if you're squaring something. That kind of makes the error worse. Okay? So I would just go, okay, that's the hypotenuse. This is the opposite. I'm going to use sine. Sine of 58 is 14 over BC. Doing the same sort of thing I did just a second ago, BC over 1 is 14 over the sine of 58. On your calculator, if you want to be exceptionally lazy, you can do second, enter, backspace over a little bit, change the tangent to sine. So we get that BC is approximately 16.51. Okay, many questions about that? Yes,
If you are not cross multiply, you would just do it the exact same way that we just did on our test. Like if you did.
you could cross multiply. You could do 14 equals BC times sine of 58, and then you're going to have to divide both sides by the sine of 58.
So then, it ends up the same thing.
Yeah. I'm just getting there one step faster. All right. Last page. So we can also do these on a coordinate grid. So the coordinates of R are at -3, 5. The coordinates of S are 4, 5. And the coordinates of T are 4, -6. Be sure you graph those correctly. Every now and then someone puts a point in the wrong place and all of their answers are wrong. And for a thing as simple as graphing, that shouldn't happen. The nice thing about this is that you can just count RS and ST. And I will only give you right triangles like this where one side is horizontal and one side is vertical. I suppose I could give you a right triangle where none of the sides were and you had to use the distance formula for all three sides, but I'm mean, but I'm not that mean. So 3, 4, 5, 6, 7. ST is, let's see, that's 5 plus 6 is 11. So we can just do the Pythagorean theorem to find RT. It'd be 7 squared plus 11 squared is equal to RT squared. And since they want me to round this answer, I'm not going to bother multiplying any of that out. I'm just going to take the square root. It'll be the square root of 7 squared plus 11 squared is RT. Somebody got that for us? 13 exactly? 0.03? Okay, thank you.
Wait, 0.4.
Yeah.
0.4? No, it's okay. And then again, just like before, if you're finding the angle measures, don't use the 13.04. That's not exact, is it?
No.
Use the ones that are exact, the 7 and the 11. So for the angle R, 11 is,
Opposite.
and 7 is,
Adjacent.
so that means
Tangent.
tangent. The tangent of R is 11 over 7. So R is the tangent inverse of 11 over 7. And I haven't the slightest idea what that's going to be.
57.5.
All right, but it said to the nearest degree.
Oh, so it's just 58.
Be 58 degrees. And the measure of angle T then? Pardon?
22.
How about 32?
Wait. So for angles, will we always just do
You'll do whatever it asks.
Will it ever be like decimals?
It might ask you an angle to the nearest tenth or the nearest hundredth. By the way, occasionally I have a student who's like, wait, you used a rounded answer. You're a horrible person. I'm like, okay. First of all, calm down. Secondly, someone read me what that was for angle R. It was 57 point what?
52880.771.
Thank you, ma'am. All right. So if I take 90 minus that answer and round it, when you're just adding or subtracting, it's not going to, if you rounded and add or subtract, you're okay. It's when you multiply or divide or square or take the tangent or any of those things that you may not be.
I probably should do that considering I thought it was 22.
It doesn't hurt. And it is nice that you can just do 90 minus answer. You guys know how to use that?
No.
Okay, so I can just type in 90 minus, and see right above the negative sign, not the subtraction sign, but the negative sign, it says A and S in blue.
Yes.
So you do second,
Oh my gosh.
and it'll take that answer and subtract it from 90.
That's crazy.
Well, it's great so that you don't have to type in a long decimal. Like if you needed all those decimal places, you wouldn't have to, type them all in again if you needed to do something else with them. Cool. Okay, so that's it for the lesson. Let me close this down and we'll talk about